Starting problem number 4, a mass weighing 3 pounds. Alright. Stretches a spring 3 inches. And inches to feet. Each one of those is 12 of those. That makes that 1/4 of a foot. The initial stretch. So what do we know from this? We know that W equal mg. So 3 equal m. And g, since it's in feet, that will be 32 feet per second squared. So m equal 3 divided by 32. We got the mass. And we know that F equal K times, we called it X, you could call it L here, it doesn't matter. F is the 3 pounds, that's the force, right? And that would be K times, and the stretching is 1/4, so K is 12, we got K as well. And if I read on, it says, okay, I got that, if the mass is pushed upwards, so initially U of 0, it's pushed upwards, and here they say up is 1 inch in feet. There's inch, there's feet, that's 1/12 of a foot. And then set in motion with a downwards velocity. The velocity is downwards with 2 feet per, okay, good, they saved us the time in converting that part. And if there is no damping, hey, no damping means what? That's 0. And they didn't say anything about external force, right? So that's 0 as well. Alright, well that's pretty much what we need out of this, and that's how we're going to do all applications. It says, find the position U of the mass, determine the frequency, period, amplitude, and phase. Okay, well that's pretty much defines everything. Well, let's see. M U double prime plus gamma U prime plus Ku equal F of t is the equation. We already figured out this is 3 over 32 U double prime plus 0 U prime plus, what did we say K was? 12 U equals 0. If I multiply by 32 and divide by 3, third time we'll get it right. If I multiply by 32 over 3, I will get U double prime plus 4, that is 128 U equal to 0. And this is pretty much how I'm going to solve the whole problem. Well, guess what? We've been doing this all along. I am going to let U equal e to the RT. U prime is R e to the RT. And why am I doing that? Because this is a linear differential equation with constant coefficients. And in turn, this problem right here becomes, R squared plus 128 times e to the RT equals 0. E to the RT can never equal 0. R must equal plus or minus the square root of 128. The square root of 128, 64 times 2. Plus or minus 8 radical 2i. Here we go. Got it. So what does that mean? That means cosine of 8 radical 2t, sine of 8 radical 2t will form the fundamental set, and the solution is that U equals C1, the cosine of 8 radical 2t, plus C2, the sine of 8 radical 2t. And there it is. We've done those over and over. What's missing now? Well, what is u of 0? U of 0 is C1, and that equals negative 1 over 12. Done. Got it. Very good. This is negative 1 over 12. And if I take u prime, which is positive 1 over 12 times 8 radical 2, the sine of 8 radical 2t, plus 8 radical 2 c2, the sine of 8 radical 2t. And I know u prime of 0 is, that's gone. I'll get 8 radical 2, that's a cosine, isn't it? You know the drill. 8 radical 2 c2 times 1, and that's a 2. So c2 is actually 1 over 4 radical 2. So my solution to this problem is actually u of t equals negative 1 over 12, the cosine of 8 radical 2t, plus 1 over 4 radical 2. You could rationalize if you wish. Sine of 8 radical 2t. And let me just double check my numbers, make sure there's no error before I go on. Okay, it seems everything's in order. What they want us to define a few things. Well, let's see. They want us to define the period. The period is 2 pi divided by 8 radical 2. They want the frequency, which is omega naught. Well, the frequency is actually 8 radical 2. They want the amplitude, that's the square root of negative 1 over 12 squared, plus, if you rationalize that, 1 over 4 radical 2. You could just write 1 over 4 radical 2 squared. And I'll accept that as an answer. You really don't have to figure that out. But the back of the book will most likely rationalize, and you get radical 2 over 8. There you go. So this will be like in place of that. Not that it matters. And if we want omega, that is, and let's see how that works. Where are we? We are in the negative and a positive. So if I want to know what this angle is, that's going to be pi minus, and I got that to be 1.13. And that's all the information that's needed for this problem. And of course I got this by taking the inverse sine of this divided by this, positive, ignoring the minus, called reference angle. Okay, this is a problem given on a handout. The handout is under files. If you look in the Canvas files. So this is the equivalent of section 3.8. I'm giving you homework on 3.7, 3.8. 3.7, the external force is 0. 3.8, the external force is given. So that's the difference between like 3.1, 3.3, 3.4, which are homogeneous, and 3.5, which was non-homogeneous. The particular solution. Nothing new, you've done all of this. So if I read this, it says a 2-pound weight, so that looks like 21, a 2-pound weight, that means W equal mg, 2 equal m, and let's see how that works. Stretches a spring 6 inches. Alright, very good. So we're talking about inches or feet. M is 1 over 16. And not only that, I know that F equal, normally use kx, they like kl here, right? Something like that. So F is 2, k, and the stretch is, let's see, 6 inches. Isn't that half a foot? So k equals a 4. I got k, right? The weight is pushed 7 inches above. 7 inches above. If I push up, inches, that is negative 7 over 12 feet. And then released. Initially, there was no, the initial velocity was 0. It wasn't pushed or that up. Find the motion after, and they gave us, in this case, the external force. That's this. And since they didn't mention anything about gamma, that would be 0, right? Alright, so I'm looking at an equation that reads 1 over 16 u double prime plus, what is that called, gamma? That was called damping. The damping cost is 0. Plus 0, that's gone. Plus 4 mu equal 1/4 the sine of 4t. So u double prime plus 64u equals 4 the sine of 4t. So here, if I look at this, I'm going to say the solution to this is the complementary plus the particular. I'm going to start with the complementary. I'm going to say this is a linear differential equation with constant coefficients. I am going to let u equal e to the rt. U prime is r e to the rt, and u double prime is r squared e to the rt. R squared plus 64 e to the rt equals 0. E to the rt times r squared plus 64 equals 0. E to the rt cannot equal 0, so it has to be r squared plus 64 equals 0. So r equal plus or minus 8i. So far I have a cosine of 8t and a sine of 8t being the solution. Now I want to go for the particular. I'm going to say the particular solution. I'm going to say that u is going to equal a the sine of 4t plus b the cosine of 4t. I don't need to modify it. So I need two derivatives. First derivative, that is 4a the cosine of 4t minus 4b the sine of 4t. U double prime will be negative 16a the sine of 4t minus 16b the cosine of 4t. Now, if I take this and add to that 64 of this plus 64a the sine of 4t plus 64b the cosine of 4t, altogether when I add those, I should get a 4. Sine of 4t. So what do I get here? If I really look at those, I'll get negative 16 plus 64, right? Yeah, I'm not mistaken. 64 minus 16 is actually 48a the sine of 4t, and b the cosine of 4t. And out of this, what I get is 48a equal 4. That means a is 1 over 12. And 48b equals 0, so b is 0. So this is what I'm getting. I'm getting u to equal c1, the cosine of at, plus c2, the sine of at. And out of the particular, I only got a 1 over 12, the sine of 4t. That would be my solution. I have my initial conditions. Let me plug those in. Initially, u of 0 or y of 0, that's c1. And that's it, just c1, right? Times 8, that's right. And that equals a negative 7 over 12. Oh, hey, that's fun. And u prime, if I take a derivative, that would be negative 7 over 12 times 8, the sine of 8t, plus 8c2, the cosine of 8t, plus 1 over 12 times 4, the cosine of 4t. U prime of 0, it's not going to matter because that's 0 and that's 0. That leaves me with 8c1, and that's going to equal a 0. That means c1 is 0. C2, right? So my solution to this problem, the answer is that u equal negative 7 over 12 cosine of 8t plus 1 over 12 the sine of 4t. So if you really worked out section 3.5, there's nothing in these applications that you don't already know how to solve. Okay, I want to do one more. This is an example that I made up. I got it from a different book. So, a mass weighing 4 pounds stretches a spring 1.5 inches. This is really 3/2. It's easier to write it as a fraction. Inches to feet, so each one of those is 12 of those. Those cancel out. 3 divides that 4 times. That's 1 over 8 of a foot. Alright, and let me figure out everything else. Actually, let me write down everything else. What else is there? If the mass is given a positive displacement of 2 inches, the initial is a positive displacement of 2 inches. That's really 1/6 of a foot from its equilibrium position and released with no initial velocity. Okay, so far so good. Assume there's no damping, even nice. You know, if they gave us damping, we already know how to do that. We played with that over and over. That would mean you would have e to the negative or e to the positive, right? The exponential. And the mass is acted on by external force, alright. F of t equal twice the cosine of 3t pounds. Alright, very good. Formulate the initial value problem describing the motion. Okay, find me the formula for that. So let's see what we know. We know that here, this is W equal mg, 4 equal m times 32, so m is 1/8. Got it. And we know here is that F equal, normally it's kx, kl, whatever. This is a 4 equal k times 1/8. That means k is 32. Alright, that's good as well. I think I have all the pieces for this equation. So the equation now really looks like m u double prime plus 0, that's gone, plus 32u equals twice the cosine of 3t, or simply u double prime plus 8, 256, 240 plus 16 equals 16 the cosine of 3t. So nothing short of section 3.5. We're going to say in this case, u is going to equal the complementary plus the particular. Well, let's see the complementary. The complementary linear differential equation with constant coefficients. Let u equal e to the rt. This is u complement. U prime is r e to the rt, and u double prime is r squared e to the rt. This becomes e to the rt times r squared plus 256 equal to 0. E to the rt can never equal 0. It has to be r equal plus or minus the square root of 256. Cosine of 16t sine of 16t would be my complementary fundamental set. Well, good thing because they're not repeating. I was trying to see if it's going to repeat right there. It doesn't. I know the particular solution. So to go for the particular solution, right? That is actually a the cosine of 3t plus b the sine of 3t, right? And I need two derivatives. U prime is negative 3a the sine of 3t plus 3b the cosine of 3t, and u double prime is negative 9a the cosine of 3t minus 9b the sine of 3t. And what is it that I know about initially? U of 0 equal 1/6. Well, let's, oh, I'm sorry, I'm not there yet. Just kidding. So here, if I take this at 256 plus 256a the cosine of 3t plus 256b the sine of 3t, that should equal 16 the cosine of 3t. So if I combine like terms, oh, what do you know, they do match. This will be 247a the cosine of 3t plus 247b the sine of 3t, and that should equal 16 the cosine of 3t. What does that indicate? That indicates that 247a equals 16 and 247b equals 0. b equals 0. But a equals 16 over 247. So I'm going to say the solution to this is C1 the cosine of 16t plus C2 the sine of 16t plus 16 over 247, that was A, the cosine of 3t. There we go. That would be my general solution. Now I do have initial conditions, and let's look at how these play. If I look at u of 0, u of 0 is C1 plus 16 over 247 C2, and that equals 1 over 6. Okay. There is no C2 there, right? So here I get that C1 is 1 over 6 minus 16 over 247. I'm going to throw this in my calculator and figure out what that equals. That is 151 over 247 times 6, which is 1,428. Okay, and so I know what this is. This right here is 151 over 1428. And I know that u prime, if I take a derivative of this, now, isn't that going to give a sign? You know what? I'll write it out. I don't want to throw you off. So here, let's take another line because it's not going to fit right here. So if I take u prime, actually, if I take u prime, that would be 151 over 1428 negative times 16, the sine of 16t, plus 16c2, the cosine of 16t, and this would be minus 16 over 247 times 3, the sine of 16 of 3t. And if I take u prime of 0, well, hey, wouldn't anything with a sine 0 out? That's why it didn't matter. When you take a derivative of this, you get a sine, derivative of this, you get a sine. The only piece that's going to be is the derivative of that. That will be 16c2. And what did we get that to equal? A 0, which means c2 equal a 0. Very good. So my solution to this entire problem, the way this graph will behave, formulate, find me a formula for u. That would be 151 over 1428, the cosine of 16t, plus 16 over 247, the cosine of 3t. So it's a combination of a cosine and a cosine. All right. And there's the homework 3.7, page 157, number 1, 3, and 21a. 3.8, page 167, number 6 and 13a. The handout number 1 and 7.